Hello and welcome. In this video, we'll break down one of the most revolutionary advancements in artificial intelligence, the transformer neural network. By the end of this video, you'll understand what the transformer model is, how it works, and why it's so powerful in modern machine learning tasks. So what exactly is the transformer model? At its core, a transformer is a type of neural network architecture designed specifically for sequence-to-sequence tasks. Unlike traditional models that process data sequentially, the transformer processes data in parallel, making it extremely efficient. The transformer model consists of two main parts. One, the encoder, which takes input data and transforms it into a set of meaningful representations. And two, the decoder, which uses these representations to generate output, like a translated sentence or a prediction. One of the key innovations of the transformer model is the self-attention mechanism. In self-attention, each word in a sequence looks at every other word to understand context. This allows the model to capture long-range dependencies and relationships between words, even if they're far apart in the sentence. Let's break down how self-attention works. First, for each word, the model creates three vectors, A, and A. It then calculates a score between the query of one word and the keys of all the others. These scores determine how much focus or attention should be placed on each word in the sequence. Finally, these attention scores are multiplied by the corresponding value vectors and combined to create a new representation for the word. Since the transformer processes words in parallel, it needs a way to keep track of the order of words. This is done through where each word's position in the sequence is embedded with special values that help the model understand the order. Compared to traditional models or transformers are much faster because they can process entire sequences in parallel. This makes them more efficient, especially for long sequences where RNNs struggle with information retention and computational speed. Transformers have become the backbone of many modern AI applications. They're widely used in natural language processing tasks such as 1. Machine translation, like translating text from English to French. 2. Text summarization, summarizing long articles into shorter versions. And 3. Even chatbots for generating human-like responses in conversations. There are also many advanced models built on the transformer architecture. BERT, which stands for bidirectional encoder representations from transformers, reads text in both directions, improving context understanding. GPT, or Generative Pre-trained Transformer, focuses on generating coherent and meaningful text. And T5, the text-to-text transfer transformer, turns all NLP tasks into a text-to-text problem. To sum up, the transformer neural network has revolutionized the field of AI and NLP by introducing a more efficient way to process sequential data. Its use of self-attention and parallel processing makes it incredibly powerful for tasks like translation, summarization, and more. I hope this video gave you a clear understanding of how transformers work and why they're so impactful. Thank you for watching. If you found this explanation helpful, make sure to like, share, and subscribe to my channel for more AI and machine learning insights. See you in the next video.